Welcome back. So, here's a really fascinating question for you. How exactly do you take a framework born from the incredibly abstract math of quantum vacuum dynamics and actually apply it to the messy, tangible, macroscopic world we live in? I mean, it's one thing to mathematically describe the universe as a geometrically constrained set of vacuum basins. That's beautiful on a chalkboard. But it is entirely another to use those exact same mechanics to, say, prevent a traffic jam or engineer biological healing. But today, that's exactly what we're doing. We are bridging that gap and taking this theory out of the vacuum straight into reality. Okay, let's take a quick look at our roadmap. We're going to cover the power of persistence, how GEM applies across multiple domains, engineering biological recovery, maintaining traffic resilience, the ultimate laboratory test, and finally bringing it all together under a unified mechanics framework. By the end of this, you're going to see how these radically different topics all fit together perfectly. Section 1. The power of persistence, from the vacuum to reality. Let's make that jump from abstract symmetry down into the nuts and bolts of everyday stability. It really begs the question, doesn't it? How do we actually test a quote-unquote theory of everything? Because a true fundamental theory shouldn't just explain why a particle has mass, it needs to explain why anything persists at all. So how do we build an experiment that bridges the microscopic vacuum of the universe with the macroscopic resilience of everyday things? Which brings us to Section 2, GEM across multiple domains, a unified language of stability. Just as a super brief refresher on the core GEM formula, because I know we've covered this, a structure only exists in a meaningful way if it maintains coherence inside a dynamical shell. Basically, a system stays viable when its persistence score, its P, stays above a minimum threshold P-min. And that score comes from three coupled axes. You've got depth, which is the energy barrier preventing collapse, stiffness, which is the immediate resistance to being distorted, and viscosity, which is your relaxation or recovery time. If you drop below that P-min threshold, the system doesn't just get a little unstable. It degrades, it drifts, or it completely collapses. What makes this framework so incredibly powerful is how it applies across basically every domain you can think of. Whether we're looking at the DNA in your cells, the neural networks inside an AI, or the literal traffic on your morning commute, the core rules of stability are exactly the same. Under this framework, a massive traffic jam and a fracturing piece of plastic are actually the same thing. They are both just systems that have fallen below their P-min threshold. Moving right along to Section 3, Engineering Biological Recovery, Body Scale Coherence. We're shifting gears from descriptive physics straight into bioengineering. Think about standard medical treatments versus a GEM-inspired biological coherence pod. Now, standard biology often looks at treating isolated symptoms, right? But through the lens of GEM, systemic fatigue or illness are fundamentally issues of lost persistence. So a coherence pod functions as a controlled body-scale persistence environment. You aren't just applying a random therapy, you are artificially manipulating the depth, stiffness, and recovery time of the patient's immediate environment. The goal? To keep their biological systems comfortably above that critical P-min threshold so they can naturally heal. It's a beautifully grounded way to test whether a biological system responds to pure engineered persistence conditions. Let's jump to Section 4, Maintaining Traffic Resilience, Corridors as Coherence Shells. We're leaving biology behind for a second and looking at urban engineering. Think of a highway corridor as literally a coherence shell for vehicle flow. A traffic jam isn't just bad luck, it is a mathematical loss of persistence. So how do we fix it using GEM? Step 1. If the corridor has low depth, meaning it's super prone to collapsing into a jam, you engineer persistence by throttling the demand, like using those ramp meters. Step 2. If it has low stiffness, where one person hitting their brakes causes a massive shockwave, you enforce speed harmonization. Step 3. If it has high viscosity, taking way too long to recover from a slowdown, you use recovery flush actions to clear out the basin. It is just a brilliant practical mapping of proactive persistence engineering in the real world. Section 5, the ultimate laboratory test, modal theory version 11. All right, let's pivot from exploratory engineering to the hard physics climax of all this. Now, what's really interesting about what we're looking at here is that this is a specific, testable laboratory thrust signature. We are not talking about a thought experiment anymore. This is the predicted tabletop thrust profile that mathematically proves the existence of the 255-degree vacuum lock of our universe. Let's break down exactly what the data is showing us. The setup here is a 10-centimeter coherence shell being driven at 1 terahertz. That solid blue curve, that shows the net sustained thrust, peaking at roughly 5 millinewtons, right exactly at the 255-degree global minimum. But the really crucial part is the red dashed curve. Those are the diagnostic plus or minus 120 degrees Z3 phase harmonic sidebands. You can think of those sidebands as the measurable echoes of the universe's underlying geometric pattern. They interact with a sort of cosmic left or right-handedness, a chiral bias, that literally locks our specific universe at exactly 255 degrees. And the rigor here is absolute. To quote the source text directly, this signature is topologically protected and cannot be mimicked by ordinary artifacts. If you run this experiment and you see this exact thrust profile with these specific sidebands, you aren't just looking at a glitch in your equipment. You are looking at a geometrically inevitable signature. It is the definitive proof that the classical quantum and renormalization group flows all converge to this one unique fixed point. Finally, Section 6, a unified mechanics framework, global consistency. Let's bring all of this home. Physical law arises from global consistency conditions imposed on admissible histories. Local dynamics, conservation laws, and constants emerge as constrained extrema of a global variational principle. Okay, so what does that actually mean for us? The crucial point is that physical laws don't just happen randomly. Constants, conservation laws, they aren't just arbitrary free parameters. They emerge naturally from a much larger global principle. Whether you're talking about the 255-degree vacuum phase dictating the masses of particles or a coherence pod stabilizing a human body, local stability fundamentally and always relies on global consistency. Which leaves us with a pretty massive provocative thought to end on. If the exact same rules of persistence govern the quantum vacuum, the flow of highway traffic, and human biology, what other fundamental constants or even huge societal structures might we eventually engineer using this framework? Could we engineer societal trust? Could we coordinate distributed civilizations? Or unlock pure energy abundance by manipulating these coherent shells? Well, that is exactly what we are going to explore in our next explainer. Thank you so much for joining me today, and I'll see you in the next one.